Okay. So we have completed. We are in the module 2. Okay. Module 2. The module is knowledge representation and reasoning. Right. Knowledge representation and reasoning. Okay. So in this module, what we have seen? First, we have seen what exactly is meant by knowledge representation and reasoning. Okay. And the second class we have seen propositional logic. Okay. Now today we will move ahead and see what is first order logic. Propositional logic means simply using those connective, conjunction, disjunction, etc. But here, as you will see in first order logic, we will use some more connectives or symbols. Okay. Okay. Now, you see, propositional logic deals with proposition. What is a proposition? Proposition means any statement. Today is raining. That is a proposition. Complete statements used as a whole, the truth values and logical reasoning involving propositions. So, we said what is a proposition and what is the truth value of the proposition and what is the truth value of the combination of propositions that we have seen, which are combined using and, or, not, etc. Propositional logic commits only to the existence of facts. So these are facts. Questions, commands, etc. do not constitute any proposition. Therefore, language which is more expressive than propositional logic is required. So propositional logic may not be sufficient to express everything that an AI based on symbolic logic requires. Okay. So we use the next level of logic known as first order logic. We have other further levels also like second order logic and so on. It is also known as predicate logic. Okay. A system aspiring to be intelligent need to be able to formulate knowledge of the world. That is what is the principle behind. You should write this down. That line you write down. A system aspiring to be intelligent need to be able to formulate knowledge of the world. A system aspiring to be intelligent need to be able to formulate knowledge of the world. Okay. Now here we are concerned about AI systems which are based on knowledge representation or using logic. So three things are required. One is syntax. What is the meaning of syntax? Which group of symbols arranged in what way are to be considered properly formed? What is semantics? Semantics means what well-formed expressions actually mean. Pragmatics. Pragmatics means pragmatism. What is the meaning of pragmatism? Practical. Okay, be pragmatic we say. That means be practical. Pragmatic. So what is pragmatism? How such expressions are to be used in real life or in the context of AI, which is based on this logic. Okay. Okay. So what is FOL? What is the difference between first order logic and propositional logic? FOL is a logical system for reasoning about properties of objects. Okay. What are objects? You will see. FOL augments the logical connectives from propositional logic. So augments means we have logical connect. What are the logical connectives? And, or, not. What else? And, or, not. Two more very important connectives. Implication, bidirectional. Okay. So FOL augments them. That means it uses them in a better way as well as it introduces new such connectives. So we have predicates. Predicate means in normal English grammar you have read. Predicate means the part of the sentence, the second part of the sentence with the subject addresses. So here also the same meaning. Predicates are that describe the properties of the objects, and we have mentioned this through. FOL has predicates, functions and quantifiers. Note it. FOL has predicates, functions, quantifiers. Only write the name. Predicate, functions and quantifier. Predicate means the properties of the objects Function means how they map to one another, and quantifier means to reason about multiple objects simultaneously. So we have two quantifiers. One is known as for all, and another one is there exists. That we will see in the next slides. So how FOL is modeling the world? World means here the world of AI, the domain. How it is modeling the domain, also known as universe of discourse. Okay, I told you that day. Suppose this class is our discussion, then this class is the universe of discourse. So we have objects, the things with individual identities. It can be a person, it can be some entity. Then properties. What distinguishes one entity from other? Relation. What relation is between different entities? Functions, a subset of relations, so which has from domain to range. Okay, that is functions. The propositional logic can see all possible truth values for statements by checking all possible truth assignments. That we do using what? How to do that? How propositional logic assigns truth values and then checks for composite statements. How it does that? Propositional logic can see all possible truth values for a statement by checking all possible truth assignment to variables. How it does that? How we do that? Truth table. Right? In truth table, we give all the combination of the statements, then combine them and see the final truth value. In FOL, each variable refers to some object in a set called the domain of discourse. Okay? FOL variables refer to arbitrary objects. It does not make sense directly apply connective to them. Okay, just like propositional logic, we have fixed statements on which we apply and or. But in FOL, as you will see, they are not basically arbitrary. So direct connectives application is not possible. To reason about objects, FOL uses predicates. So we use predicates. So how it does that, we will see. Okay. First is, what is a predicate? Write the definition. A predicate is a property that a variable or a finite collection of variables can have. A predicate is a property that a variable or a finite collection of variables can have. And very important concept of the term is called arity. Arity is very simple concept but very important. Predicates can take any number of arguments, but each predicate has a fixed number of arguments called its arity. Okay. So P x1, x2, xn, it has n variables of n arguments, so it has the arity of n. Okay. So in this case, this statement has a arity of n. So what is arity mentioned there? Arity is the word arity, number of arguments. Okay, write down. Arity is number of arguments. A predicate becomes a proposition when specific values are assigned to the variable. So we have a predicate, but how to convert that to the proposition of propositional logic? Simply assign the values to the variables. Okay. In propositional logic, we did not have such variables. Okay. For example, C is a student at VSSUT Burla. Okay. We could have a predicate like this. Write down this. P in brackets X VSSUT. Okay. So here this P, this predicate P shows that X is a student of VSSUT. Now you can replace X with anyone, this variable, who is studying here, or we can convert into Pxy, which is X is a student at Y. So it becomes more general in first order logic. Okay. The second one, he lives in the town. We could have a predicate Pxy where X lives in Y. Then we can replace that with P Ram Sambalpur, which becomes a proposition. That means Ram lives in Sambalpur. So we represent such propositions by means of such variables, and that is first order logic. Okay. What are domains, truth sets, and functions? Definition you write down, mention in your note. A domain or universe of discourse for a predicate variable is the set of values that may be assigned to the variable. Okay, that means Okay, that means this classroom may be a domain of discourse where every name refers to only this classroom. Okay, another definition. If Px is a predicate and X has a domain U, the truth set of Px is the set of all elements of U such that Pt is true. Okay, that means we have a Px predicate. Just like in our case, P may be everyone sitting here is of section A. Okay, so for everyone who is sitting in this inside the class, the truth value will be true if the statement is everyone belongs to section A. Okay, because our domain of discourse is now section A. Okay. For example, here U is this, and we have a function Px x is even. So in that case, the truth set is this. So the one I gave you the example, people belonging to section A. So in that case, everyone of this class, for all of the class, the truth value is true because all of you belongs to section A. Now if I say boys and girls, then in that case we have some only for the girls it will be true if the predicate is girls. If it is boys, then only for the boys it will be true. But overall the domain of discourse is the class. Next, what is a function? A function returns objects associated with other objects. Function definition you write, it is exactly same as we know, but it is a formal definition in logic. Okay. Functions can take any number of arguments, but each function has a fixed number of arguments called its arity. Just like predicates, functions have also arity. Arity means number of parameters that you are passing to the function. Functions evaluate to objects, not propositions, when specified values are assigned. Okay, predicates, there is a difference. Predicates evaluate to propositions, functions evaluates to objects. Okay, for example, suppose we have a function mother of x. So in that case, mother of Ram means say Kausalya. Okay, because it is an object, not a proposition. So functions specify objects. Okay, next. Okay, so this is important. Now what is the difference between propositional logic and first order logic with respect to syntax? What is a variable? Mention, just note the keywords. Even though you don't write everything, just note the keywords. First is variable. Okay, we did not have variables, only letters for propositions in propositional logic. But here we have variables, just like x, y I have shown you. A variable is any sequence of lowercase alphabet and numeric characters in which the first character is the lowercase alphabet, mother of, like that. So generally it is convention to use first letter as M. Constants. In a universe of discourse, for example in this class, we have three constants. One is object constant, is used to name a specific element. For example, your names. Your names are object constants. Okay. Function constants is used to designate a function of members. You belong to section A. So that is the function. Okay. Third one is relation constant. Some relation constant you may think of. Okay. That combines you. Okay. You have class at a particular time. There might be a relation between them with respect to the class. So that's a relation constant. Okay. Here, very important, note it. We have in connectives in propositional logic as not, जो मन करो मन नहीं आउटर सुना आउटर लिखी दियो, चला. PL ले कौन first is not, then or, and, implication, bidirectional. Okay, these are propositional logic. But in first order logic, we use two very important connectives known as quantifiers. One is the universal quantifier, a V with a line in between, is known as for all. That is read as for all. Then called existential, which is a inverse E. Okay, inverse capital E. So that is known as existential. There exists. You can mention there. This symbol V with one line in between is called for all. Then the opposite E is called there exists. Okay. For all, there exists. For all, there exists. All of you write. Hey, did you write? For all, there exists. All of you write. What is a term? A term denoting a real world individual is a constant symbol, a variable symbol, or a function of n terms. A term with no variables, only constants, is called a ground term. What is a complex statement? A complex statement is formed from atomic sentences connected by logical connectives. P is the atomic statement. It is raining, not P. Okay, that is a complex sentence. P or Q, complex sentence. P implication Q, complex statement. P bidirectional Q, complex statement. Quantified statement use the quantifiers for all there exists. A well-formed formula is a sentence containing no free variables. That means all variables has a name. That's a well-formed formula. Quantifiers. Okay. So this one is new to FOL, and this is what differentiates for first order logic from propositional logic. The biggest change from propositional logic to the first order logic is the use of quantifiers. Okay. So you mentioned the next line. A quantifier is a statement that expresses that some property is true for some or all choices that could be made. You mentioned there. What is a quantifier? That will be the answer. What is a quantifier? This should be your answer. A quantifier is a statement that expresses that some property is true for some property is true for some or all choices that could be made. Okay. Next is for all. Next is for all. Okay. So first is universal quantifier. Okay. So what is universal quantification? The universal quantification Px is the statement Px for all values of x in the universe, which is written in logical notation as, write down, for all x Px. Only write that. Only write the symbol. For all x Px. That means that predicate or function P is true for all values of x. Here, for all x is the student of this room, Px, they belong to section A. Okay, so for all x, Px. Thus, the above statements asserts that for every choice x in our domain, Px is true. For every choice x in our domain, Px is true. So for all x, Professor X implies people x. Okay, the current domain. Okay, but ideally it may be wrong because nowadays we have AI professors, right? AI is also teaching you. But when I say professor here, I am talking about people who are tenured here or employees of the university. So in that case, they are people. We have not reached the age where we have entities teaching you or robots teaching you. Okay. Then comes the existential quantifier. Is the statement that Px is true for some x in the universe. Okay. So write down below that there exists x Px. That means for some choice of x in our domain, the Px is true. For some choice of x in our domain, Px is true. Suppose P is female. Okay. So in that case, that is true only for the girl students. Okay. Or P is male, that is only true for the boy students. So there exists someone who is a girl in this room. Okay. So then, one example. This one also you write in symbols only. There exists x in bracket. There, last one. There exists x in bracket, even x and prime x. Which one is that? 2. Right. There exists x where it is even also and prime also. There is only one. That is 2. Right. There exists. I am not writing on the board because I want slight transitions. Because sometimes I put slight transitions is required, so I am not writing. Because if I say write, then it will be full screen driver. This won't be full screen. Okay. Yes. So how to translate? Just like we translated English into FOL, we'll translate this. Go. See the first one. All students are smart. How to translate that? Read it. All students are smart. What I have written? How to read it? Very good. For all X, student X implies smart X. Okay. So that is applicable to you also. Okay. All of you are smart. It is another matter that you don't choose to execute that power of yours, but all students are smart. For all X, student X means smart. Okay. Otherwise, you would not have been sitting here if you are not smart. Then the other one is, if I say there is a student who is smart, write down this. Okay. Just write the symbols. No need to write the description. How to write that? There is a student who is smart. So that I will write like, for all X, note it. For all X in bracket, student X and logical and student X and smart X. So here student and smart are functions. Student X means it is a function, and this X can be replaced with any constant, just like your name, A, B, C, whatever. Okay, all your names, it can be replaced. Okay, yes, all are smart, but some are genius. Okay, not all are genius, because you are genius in some domain. You may not be genius in AIML or any other subject, or maybe you may not be genius in electrical engineering, but you are genius in some domain. But suppose we consider our domain of discourse to be electrical engineering only. So in that case, some students are genius. So how to write that? Some students are genius. So there exists X, write down, in opposite inverse E. There exists X, student X and logical and genius X. Okay. So there exists X where student X is genius. So someone you might have developed from your own understanding, some at least one or two of your class may be genius. Okay, they have actually understanding far beyond your capability. Okay, that doesn't necessarily mean that he will be more successful than you, but they can understand that. Okay, so note what you got from here. Existential quantifier, which is the inverse E, opposite E, the existential quantifier is usually quantified with and, right? As you have seen, the existential quantifier is usually quantified with and. Next, you write down the De Morgan laws for quantifier. We have written for propositional logic the De Morgan laws. Here we will see the De Morgan laws for the quantifier. You see here, not, write down, not for all Px, not for all Px is equivalent to, जो तीनटा line अच्छी, 3 lines are known as equivalent to, they are same. Not for all X Px, there exists X where Px is not true. Okay, if it is said that for all X Px is not true, that means there exists some X for which Px is untrue. That is the meaning of first one. These are De Morgan laws for quantifiers. The other one is negation of the existential statement. The first one is negation of the universal statement. Second one is negation of the existential statement. So not there exists Px, that means for all X, Px is not applicable. Okay, so that is the this is the law, axiom. Okay. Next, nesting quantifiers. So how to nest quantifiers, how to transfer, as we will see, when we convert into clausal form, you would require this nesting of quantifiers. So write down those two statements. You need not write the description, just write down the symbol. You can see the PPT, it is available with you. If you cannot see here, you can see the PPT. You can keep it, see the PPT, no problem. Okay. But don't see any other window. You can open the PPT and keep it with you. For all X, what is written? For all X, for all Y, Pxy, biconditional, for all Y, for all X, Pxy. So you can exchange the universal quantifiers. You can exchange it. There is no issue. Switching the order of universal quantifiers does not change the meaning. Okay. Write down the symbol only. Okay. Switching the quantifier, switching the order of the universal quantifier does not change the meaning. Similarly, one can switch the order of existential quantifier. That means, how to read that? Someone read that? Read the second one. Similarly, one can switch the order of the existential quantifiers. So, how we read that? There exists x, very good. Exist y, pxy, biconditional. Exist y, exist x, pxy. There exists x. That means we can exchange them. Sit down, very good. Okay, however, we cannot change the position of existential and universal quantifiers. That is not possible. Okay, that will create error. Okay, then in that case, we have to follow De Morgan laws. Okay, now the question. All dogs bark is a universal statement. What is the negation? Negation कौन है यार? South जो रुको समझ सुनिए. All dogs do not bark. से कहला. Okay. Your take. What is the negation? जितने पच्चरी में क्वेश्चन चिढ़ा है जो ताले कौन हो तब you will get active. Okay. All dogs bark. What is the negation? Say same कहला. All dogs do not bark. Anyone? Yes. Some dogs do not bark. Okay. Don't see the answer in the PPT. Just two one good. All dogs bark होची statement. तारा negation कौन हो? कोई सारी बसी है. Some dog bark. से कहला. Okay. We'll see. No dogs bark. This is incorrect. Okay. You cannot say that no dogs bark. Okay. This follows from the De Morgan's laws. So there exists a dog which do not bark. Okay, or you can write in this way: some dogs do not bark. Okay, it's a negation. Is it true really? Kichi kukura achani yon bukon deni. Semti breed achi kukura mane karo. Some bovines they bark. Or you know kichi than na? What is they are called barking deer, right? Right? Okay, anyway. Next. Thus, negation of the universal statement for all x phi is logically equivalent to an existential x statement. There exists a x which does not phi. Okay. All VSSUT students read in the hostel. And negation will be there exists some student who does not read in the hostel. Okay. Okay, next. Negation of existential statement. That is a negation of universal statement. Some snowflakes are the same. Don't see the answer. Some snowflakes are the same. Snowflake means जो snow पड़े. Just guess it. Some snowflakes are the same. All snowflakes are not the same.
All snowflakes are not the same.
What? None of the snowflakes are not the same. Any new answer? Anyone? Sit down. Any new answer? Some snowflakes are different. See, jaha koila see type ra. Na see all koila hoga. None koila none habani. Some snowflakes are not same or different. Some snowflakes are not same. Okay. Oh, eta bhul achi. Some snowflakes are different is wrong. See, jaha koila ra theek. So his answer is actually right. All snowflakes are different. Okay, his answer is right. So negation of an existential statement is logically equivalent to a universal statement. Okay, very good. Negation of an existential statement is an universal statement. For all there exists x phi, the negation is for all x not phi. Pushing not across. Everyone loves someone. So for there exists x, sorry, for all x there exists y where loves xy. What is the negation? Not for all x there exists y where x loves y, which is equivalent to for all x there exists y where x does not love y. Okay. There is someone who does not love anyone. Is it the meaning of that? There is someone who does not love anyone. Okay. Okay. The last one. Negation of universal conditional statement. Not P implies Q. Eta likhi diyo. It's very important. Not P implies Q. Suppose gote statement. So it will be equivalent to P and not Q. P and not Q. Okay. Similarly, not for all x, Px implies Qx is equivalent to there exists x, Px and Qx. Last likhi diyo. Last is done. We might ask you simple questions based on this in the exam. Okay, distributing for all over and. Distributing there exists over and. The existential word does not distribute over or. এটা বোধহয় or না কোন চেক করো ঠিক distributing there exists over or this and hover এটা or ভুল লিখি this should be and. Okay, write this down. So next class Monday we will continue with this first order logic, some more statements and all these computations etc.